engineering fields. So first we have to tell you how our grading systems. Basically, I'm gonna assign some homework assignment to you guys, or gonna provide some quizzes online. Okay, and of course we need a representation. We're gonna classify different groups. Okay, so we'll provide you some topics, specific topics for each groups, and you can use any internet tools or whatever, computer or mathematics tools. Okay, you can use anything to prepare your presentation. Okay, of course we have the midterm and finals. Okay. So let me ask you guys a question. What material science is? From your personal perspective, what's material science is? Okay, you can think of it. Okay, from your personal perspective, how to explain the material science. So it is a very complicated system, which includes physics, chemistry, mathematics, and engineering. Okay, so what we are going to focus on is engineering. So what engineering point of view for material science? Right, we have to think of what's the processing, how to process those raw materials, and what's its structure, atomic structure. Because different structure, different nano or macro structure can influence its strengths, mechanical strengths, or chemical strengths, or physical properties, and so on, right? So finally, we have to think of what is performance, what's the product, what's the product specification. Okay, for example, we need the yielding strengths, we need toughness, right? And we need fracture strengths for some specific engineering application, right? So let's give you some general ideas of materials. Those materials that you can observe every day. Okay, for example, the most commonly we can see every day is metals and the metallic alloy, right? So what's their properties? What's their properties? What's the metal's properties? It's shine, is electrical and thermoconductive, right? And it's ductile. Compared with ceramics, it's ductile, right? So you know, oh, it's probably metal if this material has this properties, right? So you can think of, oh, those properties, what's the function of those properties? Okay. And the second materials is polymer. So what is polymer? In the words, polymers, it's just plastics, right? Just plastics. Okay, so you have to think of, oh, okay, what's the function and what's the application of plastics, right? Okay, so principally based on the polymers, principally based on chains of carbon and atoms joined by covalent bonds that we are going to introduce later. And there are different types of polymers. There are different types of polymers. Basically, it can be classified in three types. The first is called the thermoplastic. Okay, thermoplastic. And second is thermostable or thermoset. Thermoset polymers. And the third is elastomer. Okay, so what is thermoplastic? No idea whether you guys used 3D printing, 3D, you know, it's called additive manufacturing. I don't know whether you used those machines before or not. So the 3D printing technique is basic on the thermoplastic, right? So we have the raw materials like some like a PLA wire, or ABS pilot, and so on. So we can heat it. We can heat it at certain temperature. We can heat it to reach its called the glass transition temperature. So the polymer start to melt, become like viscous flow, and then we can build up the shape. We can build up the the product as we want. So as you print it, as you 3D print it, this thermoplastic materials solidified as reach the room temperature. It's become a solid, right? So that it can form, it can shape. So what's this thermoplastic is? What's the definition of thermoplastic? That means this plastic can be reversed. Okay, so we heat it, it's gonna melt. And as the temperature cool to room temperature, it's gonna be solidified, right? So this phase change, this phase transfer can be reversed depending on temperature. Okay. So the second one is called the thermostable or thermoset polymers. So what's the difference from the previous one? So the thermostable polymer is irreversible. For example, like epoxy, a glue, right? So you reach certain temperature, and this thermostable plastic solidified. As the temperature cool down to room temperature, well, it's still solidified, right? You know what I'm saying? So it's not reversible. Thermostable polymer is not reversible. Okay, it's not temperature reversible. Okay, so the third one is called elastomers. So what's this elastomers? It's like rubber, like a rubber band. Okay, so you have very large strength. It can sustain very large strength. As you release, for example, you do the tensile test for rubber band, right? So you can stretch it, it can extend, extend very long, right? So as you release the force, its length is going to return to the original, right? So elastomers, such like the rubber, it can provide very huge strength. Okay, it has a very huge strength. So what's a polymer's properties from your daily life, from your concept? Well, it's a thermal and electrical insulator, right? Right, and low working temperatures, so it cannot heat it at high temperature. Okay, and also you have very good properties such as the anti-corrosion compared with metals, right? If you need some products, maybe we don't need very high strength, but we need a anti-corrosion. That's you can use polymer, maybe. Okay. So next is ceramics. So what is ceramics? What's your stereotype of ceramics? High hardness, right? Very brittle, and it's insulator, right? And very good stability of chemicals. Okay, you know what I'm saying? So if you want to build up very hot parts, with high strength parts, and also you need the parts can be resist to corrosion. It can be stable in acid or base, strong acid or strong base. Well, you can think of maybe ceramics is a good choice. Okay, ceramics is a good choice. Okay, and also it's thermostable. It's very thermostable. Materials can reach like 1,000 or 2,000 Celsius. So that's why you can see the spacecraft. Well, some like turbines use the like ceramic coating and so on. Okay, so let's introduce the different type of materials called the composite materials. So what is composite? What is a composite? It's a mixing materials. It's artificial materials. Basically, it's a composite of at least two materials. Okay, two materials. So its property depends on the constituting materials. So what's these two materials? One is the matrix, and the other one is called the fillers. Okay, one is called the matrix, matrix, and the other one is called the filler, F-I-L-L-E-R, fillers. Okay, so we mix these two types of materials to reach the mechanical properties or the chemical properties and so on. Okay, so basically the matrix, usually it can be epoxy, and the fillers can be ceramics, can be metal, can be polymer, can be fiber, carbon fiber, glass fiber, and so on. Okay, so so what's the advantage of composite materials? So what's the benefits? If we need a high strength but low weight, so we can think of using composite materials. For some sports, like cycling, right? Like cycling or ski, right? What else? Like some sports, such like tennis, badminton. Why you never use a tennis bat or badminton bat made of aluminum alloy, right? You always carbon fiber composite because we need a very strong strength and we need a lightweight. Okay, of course, its cost is much higher than others. Okay, so you can think of, well, if you want to buy a bicycle, if it's carbon fiber made, its cost is much higher than the aluminum base, aluminum frame. Okay. So I'll give you some other examples of material science. What's the applications? For example, what's this? It's the joint, it's the hip joint, right? Hip, right? So when you're getting old, some parts of some human parts is gonna decay, right? So for example, like the joint, the hip joint. Okay, so if we want to replace, so what's the material's property? Have to be specified for hip implant. For hip implant, of course, we need a mechanical strength, right? Because you can see you have to, this head have to support the whole human bodies. So you have to be strong. Mechanically, you have to be strong. And good lubricity, right? Because this head is going to be rotated every day. twisted, rotated, right? So you have with a good lubricity. Of course, it must be biocompatible. It must be biocompatible. Okay, you cannot implant something which is not biocompatible. Once you implant this kind of artificial joint, it will remain in your body, in human body, for 10, 15, 20 years. So you have to think of a lot of the requirements. Okay, it's not easy. It's not easy. So that's the job from the materials science engineer. Okay. So this is artificial hip joint. Head is a head. Let me see the next one. So we have a head. We have this called a femoral stone. We have a cup. Sorry, this is the liner. Is the cup. Okay, so this part usually it's the plastic, polyethylene. Okay, polyethylene. Of course, you can change some other, such as the ceramics. Okay, such as the ceramics. So we have the cup, the liner, the head, the stone. So 4 parts, different type of materials. So how do you select it for 1, 2, 3, 4? You know what I'm saying? So it's not easy. It's not easy. For example, the connection between the liner and this head. When you move, when you keep moving, when you some sports, it might have some debris, right? Between this and this or this. So how do you know those debris? They may be very fine particles, fine polymer particles. So whether those particles influences the human body. So that's we have to concern. Okay. So this another materials property, such like optical property. So these three are alumina. Okay, it's aluminum oxide. Okay, so you can see its transparency is different. So we can adjust its compensation to modify its transmittance. Okay, it's the other property, material property, right? Optical property. So material science is an interdisciplinary field concerned with inventing new materials and devices and improving existing materials by better understanding microstructure, composition, synthesis, process relations. Okay, so there are some terms we can focus on. The first is called composition. Well, when we have to synthesize the new materials, we have to realize the composition. Well, we are not chemists, but we are material science engineer. Okay, you know what I'm saying? So we don't have to focus on the chemical reaction because we are not chemists. So the chemistry is quite tough for us, but we have to know chemistry. We know how to use it. So what do we have to focus on? What the material science engineer have to focus on is the structure, synthesis, and the process. Okay, we have to arrange the atomic structure. Different structure have different properties. We have to realize that, fully realize. Okay. And synthesis and the processing is the crucial issue that for us, for material science engineer, right? For example, we have to synthesize the new type of composite. How to synthesize this new composite materials? Well, you have to select the epoxy, you have to select the fiber, carbon fiber or glass fiber. Okay, and you have to mix it, and what's the composition is the optimum can reach the highest strength, the highest mechanical strengths, right? So you have to know how to select those materials and mix it, and how to mix it homogeneously. Okay, so when you get those composite materials, and we have to shape it into a useful component. For example, we have these composite materials, how to make it to form like a badminton pads or tennis pads. How? Right? Materials is useless, but components. Right? Think of it. So the structure of materials has a profound effect on their properties. So basically, we have to, for the mechanical point of view, the microstructure, okay, is what we have to focus on, macro and nano. Okay, so there's tetrahedron. There's a tetrahedron, which is a method of analyze used to consider a situation from material science engineering perspective. So what's that mean? So let's see the tetrahedron. So we have to mention before that there are 4 terms we have to concern, right? The concern, right? Composition, synthesis, process, and structure, right? Structure. Okay. Okay, so first let's think of the composition. For example, your boss asks you to develop a new materials which have some specific strengths that have to achieve. Well, at this moment, you can think of, oh, what materials should be used for the matrix. For example, you're going to make a composite materials. And what kind of materials should be used as a reinforced phase, as a filler, right? And what's the volume fraction between these two? Right? So after you decide this, and what's the macrostructure that can be? What's that mean? What's mean? Maybe the carbon fiber or glass fiber, it's not oriental, or it's rendered, or the carbon fiber is aligned. Okay, so its direction is highly affected. I mean, the mechanical property is highly affected by the orientation of those fillers or those reinforcing phase. Okay. Okay, so and then how to process, how to make a component, right? And there's the most crucial issue is the cost. Once you decide the composition, the synthesis process, and microstructure, so maybe your boss asks you, so how the mechanical strength enhanced, how many percent, and what is its cost, right? Cost, always cost, right? If, for example, if the you develop new materials and which mechanical strength is enhanced maybe 10% compared to the original product, but your cost is double or triple. So do you think this product is useful or it's a piece of junk, right? No, know what I'm saying? Okay, so the cost is the final and the crucial, the most important things you have to concern. Okay, so for this course, we are gonna focus on, basically depends on our time. Basically, we're gonna focus on these three materials: metals, ceramics, and polymers. That we can observe every day. Okay, observe every day. Even you haven't studied the material science, you haven't studied this course, but you have some ideas, you have some perspective on those materials. For example, give you some examples. Density, right? It's a material's property, right? Density. So you must know the metals, ceramics, polymer, and composite. So what's this figure tell us? What's this figure tell us? What's the figure tell us? If you are a materials engineer, so we know that usually the metal has the highest density, right? And the polymer and the composite have the lowest density. So what's the use of this figure? Right, so if you want to create, if you want to develop a new component or mechanical parts, and you need to reduce the weight. For example, some racing cars, right? Maybe made of composite, right? And let's see this. It's called stiffness. It's called stiffness. Or we say the elastic modulus, Young's modulus. I have no idea whether you guys have learned the materials mechanics or not. Well, let's just think of its, let me see. Oh, well, if you haven't started, we can think of it's a kind of hotness. Okay, it's a kind of hotness. Okay, so we still focus on these four type of materials: metals, ceramics, polymers, and composite. Well, so what we can see from these parts, from this figure, what we can get from this figure. Well, for these three, metals, ceramics, and composite, well, their stiffness are quite similar, right? Compared with the polymer, right? Their hardness or their stiffness are quite similar. However, if we compare with the previous figure and this figure and previous one, so what we get, if you want a very high hardness, high stiffness, and light weight, we have to choose composite, right? We have to choose composite. Okay. And then it's the strength, mechanical strength by tensile test. Okay. I will introduce you this later, but at this moment, just to realize, okay, it's the strength, okay, how strong the materials is. So what you can observe, well, the metal strength is similar to composite, right? Composite. However, composite has the lowest density. So if you want to make the strength, which is similar to metal, but we need a very light weight, we can select composite. Okay. What's this tell us? It's electrical conductivity. Well, if you want to build up a component or parts, which is insulator, the requirement is the parts has to be insulated. So we have to choose ceramics and polymer, right? We cannot choose metals and semiconductor. Know what I'm saying? So you have to fully realize what's your product's properties or product specs. So materials in each group has their properties. We are also interested in load-bearing mechanical property of the materials from our mechanical point of view. Okay, so next we're gonna realize some terms, some terminologies of the mechanical properties. The stress. What's the meaning of stress? It's the load or force per unit area, right? Per unit area. That's been the force divided by area. So what is strain? Remember, I've mentioned the elastomer, which has very huge strain. It can sustain the huge strain. What's that mean? That means the elongation or change in dimension divided by the original dimension. Okay, and strain is caused by stress. So if stress goes away after stress is removed, it's elastic. Otherwise, it's called plastic. So what's that mean? So what's this means? So think of the materials. Think of a parts with a rod. Think of a rod, which is apply a tensile stress, which is pulling from the two ends, right? From the two ends. So you can think of its length must be changed, right? Must be changed. Must be elongated. So after the stress relieves, after the stress released, the elongation will return to its original dimension. It's called the elastic. On the other hand, when you apply a tense stress on a rod, will release the stress or force. Well, its length changed permanently. It's called the plastic strain. It's called plastic strain. Okay, so I'm gonna introduce this deeply later, not in this first chapter. I'm gonna introduce this later. So you can look at the figure of this. It's called the classification of functional materials. So you have to think of, oh, we have to use some components in the biomedical industry or in the electronics, or we have to use it in aerospace structure and optical materials. So different applications has its specific property you have to think of. So that's why I mentioned in the very beginning, the material science is very complicated. Okay, it's very complicated. It's not easy. It's not easy. Okay, so let's focus on the structure. Let's focus on the structure. If we look into the materials, which is built up by atoms, right? By atom arrangement. So how to arrange those atoms? How to realize which atomic arrangement has what kind of mechanical property or what kind of electric property. So we have to realize these two classification of atomic structure. Okay, first is called the crystalline. The second one is called amorphous. Amorphous. So crystalline means atoms arranged in a periodic fashions. Okay. Also, the crystalline materials classify into single or polycrystalline. Okay, so single crystalline, which has the crystalline materials consisting of single crystal, and polycrystalline, which has the crystalline materials consisting of the multiple crystals or grains. I will talk about this later. Okay, so give you guys a very basic concept. For example, for silicon, right? The biggest semiconductor manufacturers is in Taiwan, right? TSMC, and they always use single crystal. Single crystal. Why? Why the single crystal is important for semiconductor industry? Because we have to work on the different pattern. Maybe it's nanoscale. Okay, we have to use a lot of chemical process, right, to build up those nanostructure. So if the wafer, silicon wafer, is not single crystal, we cannot predict, okay, what's the feature will be after chemical etching, right? In other words, what kind of industry has to use the polycrystalline silicon, polycrystalline silicon? Like solar panel, right? Solar panel. Okay, in solar panel, we don't need a single crystal. We just need a silicon. Okay. And the second one is called amorphous. So amorphous means the atomic arrangement lacks long-range order. Right, so amorphous means the atomic range is short-range order. Okay, so what is long-range order? So what is short-range order? So long-range order is similar to the periodic fashion. Right, we have a unit or long units, and it's arranged in periodic fashion. However, short range order means maybe we have a short units arranged randomly. Okay, let's see this. So the first one is the crystalline structure, right? So you will see the atoms arranged periodically. Okay, and the second one is called the polycrystalline. Okay, partially crystalline. So this part is crystalline, and this part, and this part. Okay, so we have 3 grams. 1, 2, 3. Okay, and the third is the amorphous. There's no any structure that can be observed. It's random. Okay, it's random. Okay, it's random. Okay, so let's look at the environmental and the other effects. So the structure property relation in materials fabricated into components are often influenced by the surroundings, That's the environmental issue. What's those issues? For example, temperature, corrosion. That's what I mentioned before, right? Corrosion, fatigue, or strain rate. So for example, you're gonna build up a submarine, or you're gonna build up the ship, right? Or a submarine. So the submarine is always under sea level, right? Over years or over months, I don't know. But so what's the properties of its shell, the submarine shell? What's the environmental conditions for the submarine shell? Maybe it's gonna what? Right. So when the metals is immersed into the seawater, what's gonna happen? The corrosion, right? Corrosion occurs always. So how do we solve this problem for a submarine? So we have to think of it. Okay. And some other issues like fatigue. What kind of parts, what kind of mechanical components is repeated loading and unloading? Right? So the repeating load and unloading, the fatigue will just dramatically influences its mechanical property, right? So how do we enhance it, or how to improve the material's property to resist fatigue? Okay, and if the some materials have to be placed in a high humidity and high temperature environment, so what we should do to prevent from the corrosion fatigue? Okay, so you have to think of it. This not it's not easy to answer. Okay, so for material science engineers, you have to always concern those environmental effects when you are deciding the developing the new materials that may be used in like the tropical area, or they may be used in the some dry environment. Okay, so there's a air crash. Okay, air crash. So we have to think of what's the reason. Okay, what kind of reason caused the air crash? You can think of it. What's the main issues to cause this air crash? Maybe it must be something wrong, right? Must be something wrong. So you can think of it and list some reasons, some possible reasons, and then we can discuss later. Okay. Okay, so for the design and selection point of view, a number of factors must be concerned when you design and selecting the materials for application, right? That's what I've mentioned before. So some basic engineering considerations you have to focus on. For example, what is the mechanical and physical property? Okay, and it must be capable of being processing or manufactured into design shape. You have to make a shape, but not just some materials. You have to process the material into a shape, okay, into a shape, and it must be economical for the application. Okay, so what's this mean? That's mean the cost. Okay, the cost. In recent years, the environmental issue is quite important. So you have to think of the materials you use. Well, has to be recycled or it can be reused. That's the best choice. Okay, that's the best choice. So it must be environmentally friendly. Okay, so often multiple materials can be used in a situation, and engineers must be consider various trade-offs to determine the optimum choice. Well, basically, recent years the simulation becomes more important. So before you design materials, before you design a component, you can try to simulate it first, okay, to realize it's first, well, whether this material design that is match your consideration, okay. Okay, so this is the first course of material science engineer. Hopefully this course will give you some basic concept to realize what we are gonna do. Okay, so yeah, so that's it. So we are gonna see you. Hope we can see you next week. Thank you.